Alright, Crewton Ramone's houseofmath.com. This one is not intuitive, and you need to know some math to do this one, and I swear they make it harder on purpose. But let's just go over it very quickly. Well, or not so quickly. This will probably take 15 or 20 minutes to cover. Look. And see, it starts off super easy, and then they give you some stuff that make it look that supposedly somehow this made it more confusing to the student, and I don't know why, but actually I do know why, because they're not used to seeing this. Anyhow, let's just draw a really simple picture of A, B, and C. Here is our triangle, and basically what it is we're finding the function of the hypotenuse in terms of the perimeter, right? Given that the area is 25 and that the A times B is 50. Well, obviously, right? Okay, and by the way, that whole thing about the area being 25, who cares? Right? Again, that's dicta. But this is important, and this part is important. But of course, if A times B, right, just find 1/2 base times height, again, right? And using A squared plus B squared equals C squared, we're fooling around with triangles. Triangles are hard to count, rectangles are easy to count. So obviously I take, well, not so obviously, if it was obvious I wouldn't be making these videos. A times B is 50. Well, then the area, of course, is going to be half of that, which is how I got 25. Alright. But now, here's the other thing. We're talking about C again, put one thing in terms of the other, and soon you'll be doing lots of math. C is the hypotenuse. Okay, so we don't like A squared plus B squared equals C squared anymore, right? Which means that if A squared plus B squared equals C squared, then of course C squared equals A squared plus B squared. But you know what? We're going to use H. I should put that here and make the color different, because now instead of saying C, we're going to say H. That's all it is. Okay, so now, obviously, if H squared equals A squared plus B squared, then H is the same thing as A squared plus B squared, square rooted, right? H is the square root of A squared plus B squared. These are the same thing. That's where that comes from. See, and immediately you put the students off, or in the problem, because they see H equals the square root of A squared plus B squared, and that looks all complicated, and square root symbol and squares and all that stuff, and all it is A squared plus B squared equals C squared. And instead of saying C, we're going to put in H, right? Because that's going to be our hypotenuse, which is what C really is, so we just put C in front. Okay, so now we're doing some substitutions already, but now we're just getting comfortable with the problem. Okay, now, like I said, you have to know something about algebra and squares and fooling around with algebra. And that just comes from playing with algebra, seriously. So I'm going to set this thing up, and I'm going to say, look, you know what I'm going to do? Here's what I'm going to do. I've got till here, or I've got till here, and basically what I'm going to do is I'm going to say, alright, if I know this much, then you know what I'm going to do? I'm just going to add 2ab to both sides. Well, why am I going to do that? Well, I'm going to do that because this will turn this into a square. Because again, we do rectangles and squares. We like rectangles and squares. We don't like triangles. Triangles hard to count. Squares are super easy to count. Rectangles are pretty easy to count too. Right? Squares are super easy to count because everybody the same, right? All I have to know about is one side. So then I can really have a fun time. Okay, so now all I'm saying is that if I add that to that, oh, look at that. That should look familiar to some people in algebraic form with A's and B's, not instead of X's and Y's or using X. But A squared plus 2ab plus B squared is going to be exactly the same thing as A plus B squared, right? Oh, look, there's my squares. Our friend makes things easier because I made a square. I got a square in all of this gobbledygook. Alright, so A squared plus 2ab is the same thing as A plus B squared. Whoopee! Oh, we're not done. What we got to do? Well, how do I get to this next thing? Well, okay, well, here's what we could do. Okay, now I know that what's AB? AB is the same thing as 50. That was a given from the problem. I'm going to pop that back in there. And now I've got that. I say H squared is the same thing as 2 times 50, right? And that's easy. That's just 100. It's a nice square number, by the way. Anyway, and now what? How did I get this? How did suddenly I went from AB to PH? Okay, once again, substitution, one thing in terms of the other. And the question asked us we're going to try to find the hypotenuse in terms of the perimeter, right? We're going to find the function of the hypotenuse in terms of the perimeter. Okay, so AB is not what's happening here, is not going to help us with the hypotenuse and the perimeter. The hypotenuse and the perimeter are going to help us with the hypotenuse and the perimeter, right? That actually should make sense to you. But where did this come from? Well, here's what I know. And again, this is just, by the time you're in pre-cal or calc or even advanced algebra, you should know that perimeter of a triangle is just A plus B plus C, right? The sides of the triangle. Well, now we just substituted again. There's our buddy H, got getting us in trouble. That's the guy that's always causing the problems here, is the H. So remember that we don't want C anymore, we want H, because we're going to talk about the hypotenuse. Okay. Now we're going to talk about the perimeter. So now we can start talking about the perimeter in terms of the hypotenuse. What's the, one is the other. Okay, so now here's what I've got. I'm just going to fool around with algebra and say that, look, the perimeter minus the hypotenuse is the same thing as A plus B. Let that sink in for just a second. That's really simple, right? I just, hero 0, just subtracted the H from both sides. Got a 0 over here, so I'm not even going to write it. And there is my negative H. Subtracted H from both sides. Okay, so now, and I could do more algebra and fool around with that, but I'm not going to. It's not necessary. But I mean, just, putting one thing in terms of the other. We could put it in terms of A, we could put it in terms of B, we could put it in terms of H, right? But none of that's useful. I just want to say that, look, I know my AB, A plus B, is the same thing as P minus H. See where it comes from? Okay, so see the thinking you got to do there? This is the mathematics. Like I said, it doesn't boil down to just computation. You have to be able to do some reasoning and thinking. So, AB is the same thing as P minus H. It says it right there, and that's how I got it. By substituting my H in for C, and then figuring out what the perimeter was, or what how the perimeter is in terms of the whole thing. It's P equals A, B, C, A plus B plus C, and then I put my H in, and then I do that. Okay? Alright, because it's just like I said, we spend a little time with it, and professors and teachers tend to rush through this, and it's like, oh, okay, I get it. Easy. Alright, so, and some of you guys are wanting to fast forward because I'm spending too much time on it, but, we gotta make make allowances for whoever the student is that's watching, those that need extra help and those that get it right off the bat. Alright, so, and like I said, when it came to the algebra, I had no problem with this stuff, but when it came to the calculus, I was like, huh? Wait a minute, could you explain that? Why again? And unfortunately, I had a teacher that could not explain it. And he wasn't one of those teachers that pretended either. He knew he couldn't explain it, and he was put in a very difficult situation. Now, looking back through time, I see that the guy was put in a teaching calculus, and he knew he didn't know calculus well enough to teach calculus, and he was just kind of stumbling through it with us. And he explained that to everybody going in, because we just didn't have a calculus teacher. So he was pretty much, it fell to him. Anyhow, and then when I finally got in front of a teacher that could teach calculus, it was too late, but okay, I started to go, oh, okay. And then when I ran into this guy named Jerry Mortensen, it was like, oh, okay, now it's very simple concepts that we're dealing with here. And you see that really this stuff is pretty basic. Okay, but getting back to, okay, all we did is substitute. We're doing substitution, substitution, substitution. We're saying one thing equals another thing. We love the equal sign. The equal sign never lies. There it is there. C is the same thing as H. Over here, P minus H is the same thing as A plus B. So we just stick that in. We got that. And why did we do that? We got that because we wanted to make a square. And why did we do this? Because we wanted to make a square. Because making a square is easier than having a rectangle or a triangle. Okay, so, and by the way, a square is a kind of rectangle, right? Okay, so now I just have this, and now I just expand again, right? First we expand, then we got some, and then we go to put that, and then we expand again, right? Where we just squared it, and lo and behold, we have that. But the reason why we do that is because now I have same stuff on both sides, right? This is a simple concept. Look, I have H over there and H over there, so we can cancel. I mean, just get rid of it. It's extra. And people say, well, how could we just get rid of it? Well, look, I'm just going to this is the same on that side, and this is the same on that side. Might as well get rid of it. Don't need it there. All this other stuff is different. But this and this, that's just extra stuff. So we get rid of the h squareds. And I can just, I can subtract h squared from this side and subtract h squared from this side. Okay. And see, people get confused on when to cancel when you're multiplying. But if you understand that we're just talking about same on both sides, well, this is same on both sides. Get rid of it. Very simple concept. Okay, so now I have finally come to the place where I'm pretty much done. Where I have 100 equals p squared minus 2hp. That's the perimeter squared minus 2 times the hypotenuse times the perimeter. That's what the 100 is. Where did I get the 100? The 100 is basically because I knew that a times b was 50, and I stuck it in here. Okay, and that's easier than 50 is better than saying a times b, because it's just 50 instead of a times b. But I could, if I wanted to get crazy, I could say this is 2ab, but that doesn't help, right? I want to get all the other stuff out of there. I want to get all the a's and b's out. I just want it. What are the terms I'm looking for? Perimeter and hypotenuse. We have accomplished this now using algebra, where all the only terms we have now are perimeter and hypotenuse. Now I want to put one in terms of the other. I'm going to put this equation in terms of the hypotenuse, right, as a function of the hypotenuse. That what is the hypotenuse? The hypotenuse is this. Okay, right now the hypotenuse is buried in there, so I've got to figure out how to get the hypotenuse out of there, and that's really simple with algebra again. So here I have 100, I just rewrote it, and then I have 100 plus 2hp, that's now this, right? Just add it to both sides, 0, 0, right? Simple concept is now the same thing as p squared. And if I wanted to put everything in terms of p squared, I can't really, because I have that extra p. We don't like this one. We don't like it at all because it's got p on both sides, and we don't like it when that happens. Anyway, but I can do it in terms of h. So here then is that. So now you guys should be able to get from here to there easily, but I just want to put every single step in there so that there's no question. Okay, so now, this is just really simple basic algebra. So now I just subtract 100 from both sides. Okay, because I'm going to try and isolate and put my h on the one side, and then even more than that, I'm going to make sure my h is okay. And I skipped a step where I'm not going to divide out 2 and p in 2 different steps. I'm doing it all at once. So now I have this, and then I just want h by itself, so I divide out 2p. There's the 2p, and that's it. I'm done, right? H, right? What is h? Well, h is the perimeter squared minus 100 divided by 2 times the perimeter. That's what h is in terms of the perimeter. Okay, as a function of the perimeter. If I want to figure out what h is, if I know what p is, if I can figure out what p is, I pop it into this formula right here, and it'll tell me what the hypotenuse is. It's kind of fun. And you might see it like this. Sometimes I've seen it on standardized tests where they do both things, right? Or actually they don't do both things. They give you this instead of this. You wanted this, or they give you this instead of this, and you should be able to understand that those are non-different. Those are exactly the same thing. Alright, so what have we done here? We have figured out what the hypotenuse is as a function of the perimeter, right? Or wait a minute, did I say that correctly? No, yes, the function of the hypotenuse in terms of the perimeter. There it is. In other words, what is the hypotenuse if we know what the perimeter is? That's basically all it boils down to. Okay, lots of algebra, and where does it all come from? And it looks look at how complicated that looks, but it's not that complicated. All we're doing is fooling around with a triangle, using our friend the square to help us out, and we got there by knowing a little bit about what these are. And this is why it's important for kids to fool around with x plus 1 squared and x plus y squared, and know that you're going to get that and be able to factor these back and forth and be able to do this since they were 5 years old or 6 or 7 years old. It's easy, right? This is one of the most basic ones, but you'll see me fooling around with kids with this one a lot because it's going to show up. And again, it brings us back to the concept that teachers that teach primary school, they wind up getting a teaching degree with very little mathematics. with the requirements for primary education don't involve a whole lot of math and higher level math and analysis and so forth. So they have a difficult time preparing these kids for that quote-unquote higher level math, because they don't know about, you know, emphasizing squares and being able to factor and so forth. Anyhow, this is also another you know, very common algebra problem. What's the word I'm looking for? But I mean, this is again a perennial problem, a problem that you're going to see in every algebra book in any language on the planet that teaches algebra. This is going to be one of the problems that you're going to see when you get to the more advanced algebra, or is where you're starting to call it in the United States pre-calculus, where we start to express one thing in terms of another. Okay, there it is. Hope that helped. Long video. Go to Crewton Ramone's House of Math for more.